Alright, a parachutist jumping out of a plane will accelerate freely under action of gravity, and then reach a constant terminal velocity. So accelerating until it reaches a constant terminal velocity. And what we have to do is sketch the distance versus time and the speed versus time for this situation. Alright, so I'm going to actually start with the velocity first, because that's what the speed first, sorry, that's what I feel more confident about. Alright, so basically we are going to have a constant action of gravity, so that'll be acceleration acting on it, so it will start with zero velocity, because when it jumps out of a plane it has a zero velocity, and then it gains its speed, and then it says constant terminal velocity, meaning when it reaches a certain point, it's just going to be constant for a bit until the end. Right, so let's now use that understanding and try to draw a distance versus time graph. So when it first jumps out the plane, obviously it's going to be 0, and then as it kind of progresses and parachute opens and it starts to slow down, it is covering distance but not as quickly. So there's kind of two options. There's that way or that way, and if you have a think about it, this kind of tells me, this number one graph tells me as time goes by, it gains more and more kind of distance, but in reality, as time goes by, second one shows you that it gains kind of less and less distance, which makes sense. The parachute will open and you'll slow down, the gravity will slow down and you won't be accelerating at the, or you will be, but the constant terminal velocity will be effective and you won't be traveling as fast anymore. So it'll actually be number 2. So I'm going to erase that one. Right, 7. A ball is thrown vertically into the air and returns to its original position. Ignore the effects of air resistance and sketch the distance versus time and speed versus time for this situation. Alright, so a ball is thrown vertically into the air. So again, I'm going to start with my velocity vector because I found that easier, but it's up to you. So as you can tell, hopefully when it's thrown in the air, you can hopefully not understand that it's going to end up at a 0 at the halfway point. So when it's gone up and then gone down at that height, maximum height, that hopefully velocity is 0, and we've done that from equations of motion. So we have to kind of start somewhere, end up here, and then go back. Well, when a ball is thrown vertically into the air, it is thrown with an initial velocity. So let's just say around there. You're just going to connect the dots, and because the acceleration is constant, you're just going to have a straight line. Alright, so it's going from here and then down because the velocity is going to decrease as it goes up because the acceleration is pulling it the opposite way, the gravity, and then once it hits the top, it's going to be 0 instantaneously at the spot, and then what's going to happen is it's going to gain velocity and then end up back over here. So that is my speed graph and my distance graph. Okay, let's have a look. So at this point here at the maximum height, that it's not gaining any distance, it's instantaneously not moving. So I know a halfway point, it's kind of going to stay stationary for a second, or like the time instantaneously. So before then and after then, it is going to be covering some sort of distance, and it's not going to be a straight line, because hope you understand that velocity is increasing and decreasing. So it's actually going to be a bit of a curvy line. So here we go. So it kind of covers distance. It's going to be instantaneously a 0 slope, and then it keeps going, something like that. Now for the same situation, sketch the displacement graph. So I'll draw an arrow, a velocity graph, so I'll draw an arrow, and an acceleration graph, so I'll draw an arrow. Well, that's easy. Acceleration, I'm going to start with that one. That is going to be negative 9.8. So it's just going to be a straight line at negative 9.8. You can put a little negative 9.8 if you wish to. Right, let's try velocity. Velocity up at the top, it's going to be 0, so I know, it passes a 0 at the halfway point. But what happens? Well, when a velocity, you go up, it increases. No, sorry, it decreases. The velocity decreases, so it's going to start at some point. It decreases at a constant amount, and then what's going to happen as it comes down? Well, it's actually going to gain some velocity, so it will go down like that. And that's it. Now, my displacement graph, so this is going to look a little bit different from my distance graph, as hopefully we understand it actually started here and ended up back at the same point. So, if it started here, it has to end up at the same point. And what's going to happen in between is it's going to go really far away from it, but it's going to come back down. So we have to pick a point, let's say here at the halfway point, and then it's just going to go up there and then come back down. Basically something like that. And that's it.